Hello, my name is Kevin Holmes. I'm a business solutions architect for the global virtual sales and engineering team in the Americas. I am here to talk to you today about the foundations of local area networks. I've drawn a basic local area network diagram here. Each of these boxes represents a switch, and each switch is interconnected together. We've got several different layers here. What's commonly referred to as the core is the top layer, so these are core switches. The middle layer is referred to as the distribution or sometimes the aggregation layer. So these are distribution switches and these are access switches. This three-tier model works really well in very large environments. If you think about a campus that's got multiple buildings, of course each floor is going to have access layer switches and the endpoints are going to be connected to those. Those access layer switches then feed into the distribution or aggregation layer. So within that building there's probably a distribution pair of switches. And then in one of the buildings, there's going to be a pair of core switches that all the distribution switches feed into. Now, in smaller environments, when you don't have multiple buildings or you don't have a big high-rise with 30 or 50 floors or something like that, if you've got maybe just a single building or even maybe one floor within a building, you don't necessarily need this three-tier model. So we see companies collapse these two together into a collapsed core. So essentially we're eliminating one of these two layers and you end up with a topology that looks more like this. So all of the access layer switches just feed directly into that collapsed core because it's unnecessary to have all three tiers in that kind of a scenario. Now the capabilities of these switches can differ. So we have concepts called layer 2 and layer 3 functionality. So layer 2 essentially just means that this allows us to segment our network into different virtual segments or virtual local area networks, often referred to as VLANs. So we do this partly for security reasons, partly to shrink the size of our network. So we create these boundaries called VLANs, and you can put an individual port within a switch into a VLAN. So you can do that on a layer 2 switch, and all of the clients on a particular VLAN can talk to one another and communicate with each other, but they can't communicate with clients in other VLANs. So to be able to communicate with clients in other VLANs, you need this layer 3 capability so that the data can be routed between those VLANs and clients on different VLANs can still talk to each other. So typically you have your core and distribution switches are going to be layer 3. Sometimes even the access layer is layer 3. The reason that a company would do that is to speed things up. If this access layer is layer 2, if communication needs to go between VLANs, that traffic has to be passed up the chain to a device that has that layer 3 capability. The traffic is routed and then the response happens the same way. If you have layer 3 at that access layer, then that all happens within that individual switch. So these uplinks, let's talk about them for just a minute. These are typically fiber. In fact, it's highly recommended that they be fiber. What type of fiber optic cable, how fast that connection is depends on the connector that these fiber optic cables plug into. So these connectors are called transceivers. And the types of transceivers that we see most commonly are SFP, which is a 1 gigabit connection, SFP plus, which is a 10 gigabit connection. We have QSFP plus, which is a 40 gig connection. And we have QSFP SFP28, which is a 100 gig connection. What all these mean, the SFP means small form pluggable. It's just referring to the previous generation before the SFPs were a larger transceiver. So that just means small form in comparison to the previous generation, which was larger physically. And then pluggable means that these modules plug into slots in the switch. So all of these connections that are going to be in our core and distribution layer are going to be fiber switches that got slots that you slide these modules or transceivers into, and you choose the one with the speed that you want to use. So the plus was added to the SFP when the 10 gig technology came out. The Q means quad for 4, so 4 times 10 is 40. The Q in SFP28, we're actually multiplying by 28, so 4 times 28 is actually a little bit more than 100, but they round to 100 just to make things easy. So that's what those transceiver technologies are and what they mean. We also have PoE, or Power over Ethernet, technologies. So the PoE standard means that a switch's port will supply 15 watts of power to a device that's on the other end of the cable that's plugged into that port. PoE plus will supply 30 watts of power, and UPoE will supply 60 watts of power. It's important to understand the distinction between these because different endpoints that are plugged in might need different levels of power. For example, if you plug in a very basic phone, it might only need 6 or 7 watts of power. So a switch that's got the regular PoE standard, which is going to be less expensive than the UPoE switch, is going to be appropriate. If you've got an advanced wireless access point that requires more than 30 watts of power, you're going to need a UPoE switch that's capable of providing that much power to the endpoint device. So we need to understand what devices our customers are plugging into these switches when we're speccing them out. Another concept that applies to Cisco switches is a technology called MGig, or multi-gigabit. To go back to the wireless access point example, many of our latest wireless access points will communicate at speeds greater than 1 gigabit, which is the typical speed of an Ethernet, a copper Ethernet port. An MGig port allows speeds up to 10 gigabits, depending on the quality and the length of the cable that's connecting to that device. So you get 10 gig. If the cable's a little too long, you might get 5 gig or 2.5 gig or even 1 gig as a fallback. So the models of the switches that fit into these categories are core switches. We've got the Catalyst 9600 series, which replaced the old Catalyst 65 and 6800 series. This is a chassis-based switch with slots for line cards. So it's got a couple of supervisor line cards that slide into that chassis. Those supervisors control all of the functionality of the switch. And then the remaining slots have line cards with ports in them. So they'd be fiber ports in this case in the Catalyst 9600. So this is a 6 rack unit chassis. So it's got 6 slots in it. The distribution or aggregation layer, the latest and greatest there is the Catalyst 9500 series. There are various models that have SFP plus or QSFP plus, QSFP28 ports on them. These could be replacing old 4500Xs or maybe even a 3850 fiber switch. The access layer, we have the Catalyst 9400, 9300, and 9200. The 9400 is also a chassis-based switch with supervisor modules similar to the 9600. The difference being mainly the line cards that fit into the Catalyst 9400 are generally going to be copper-based. They could be MGig, they're going to have PoE. So you've got these options because they're plugging into access layer devices like PCs and phones and things like that. wireless access points. The Catalyst 9600 is strictly for uplinks, so that's why they're fiber ports. There's no such thing as PoE on a fiber port. The 9300 is the fixed switch, so it's one rack unit that can stack together. As I've drawn them here, the 9200 also can stack together, but at a slower speed. There are more options on the 9300. The 9300 can also function at layer 3 with the appropriate licensing, where the 9200 can only function at layer 2. We could also use Meraki switches, so like the MS 100, 200, and 300 at the access layer, and we could use the Meraki switch MS 400 at the distribution or access layer in, say, a Meraki network. There are also industrial Ethernet switches that could be at this access layer that are designed for very harsh environments like warehouses, manufacturing facilities, utility substations, things like that. We've got an entire portfolio of industrial Ethernet switches that fit into this category as well. If we've got a wireless network, which most companies do, we have APs, or wireless access points, connected through our switches and generally powered by the switches. So these exist all throughout the environment and are actually controlled by a device called a wireless LAN controller. So all of the administration and instructions about the wireless access points and their configuration goes through this wireless LAN controller. The current model of wireless LAN controller is the Catalyst 9800, and there are kind of small, medium, large configurations for that. Those take the place of the old 5520s, 5508s, 3504s, 2504s. So that's the 9800. The wireless access points, the current generation are the Catalyst 9100 series. So there's a 9115, 9117, and 9120 currently. There will be additional future models coming out in that 9100 series. These take the place of the 3800, 4800, 18, 2800 series, which were 802.11 AC Wave 2 access points. In contrast, the Catalyst 9100 series switches are the next standard, which is 802.11 AX, or sometimes just referred to as Wi-Fi 6. So that standard and Wi-Fi 6 are pretty much synonymous. And then, of course, there are older models of access points as well that we would be replacing. To control this environment, we can implement the Identity Services Engine to control policies about who gets access to the network, how the network is segmented. So rather than segmenting by VLAN manually configuring each individual switch, you can set those policies on the Identity Services Engine. So think of that as the policy and control engine for the environment. To configure all of this, we can use the Cisco DNA Center controller. And actually, we would use more than one. One is really reserved for proof of concept and lab environments. If we're going to control a production environment, we want 3 DNA Center controllers at minimum. Very large environments might need 5. But this will control, it will interact with the Identity Services Engine and push out configurations, do things like DNA assurance, which is looking at the environment, looking at what's going on, and alerting the administrator if there are any challenges, maybe even predicting fixes to those challenges, and giving you a one-click, click here to remediate kind of solution. But let's talk about the software licensing. Oops. So we have 3 levels of software licensing. We've got the DNA Essentials, DNA Advantage, Advantage, and DNA Premier. So DNA Essentials will provide basic functionality like Layer 2 functionality for whatever device has this license. We get monitoring, just basic monitoring and configuration. So we can push out configuration to these devices through the DNA Center controller that only have DNA Essentials licenses. If we want the real functionality and what you would really buy a DNA Center controller for, we would need to license the devices with DNA Advantage. And that's an important distinction to understand. You're not licensing the DNA Center controller, you're actually licensing the individual components in the network, the switches, the wireless access points, even the routers, if you want to control them with the DNA Center. So here you get software-defined access. So we're defining in software that's running on the DNA Center controller how the network functions and how it interacts and how it communicates. We get encrypted traffic analytics where the switch is examining a data stream that's passing through it and determining whether there's any malware within that data stream, within that encrypted data stream, without actually needing to decrypt it, which saves a ton of overhead on these devices, a ton of cost as well, to provide an additional security feature for that environment. You also get assurance with the DNA Advantage licensing, which I covered briefly a few moments ago. Last but not least, you get Layer 3 functionality with DNA Advantage. So if you've got a customer that says, I need a Layer 3 switch, and you're selling them one of these Catalyst 9000 series, they need DNA Advantage. If they say, I need a Layer 2 switch with basic functionality, then they need DNA Essentials. DNA Premier provides everything that's in DNA Advantage, but it also adds licenses for ICE, Base, and Plus. So that's a requirement for software-defined access to have ICE licenses, and a requirement for encrypted traffic analytics is to have StealthWatch licenses throughout the environment. So to be able to do that inspection without decrypting an encrypted stream of traffic, you need a StealthWatch subscription.